right, here we go. Question number 24 in our pre-calculus homework number 12 in MyLab Math. Again, they want us to write the partial fraction decomposition of the given rational expression. And so the first thing I want to do is copy this rational expression into our scratch work and talk about how we're going to break this down. So back here in our scratch work, the denominator will not factor. In fact, we have the sum of two squares in the parentheses. But what I notice is it is an irreducible quadratic, and it is also repeated, right? Because whenever you square something, that means to multiply by itself. And so this quadratic factor appears twice. It is a repeated, irreducible quadratic factor. And the way we're going to set that up, in order to use our partial fraction decomposition, every power of the quadratic factor has to be represented in its own fraction. So x squared plus 4 to the first power, which would just be itself. And remember, your quadratic factors have to have linear numerators. So that's going to be ax plus b. I have no idea what a and b are. Those are my variables. And then we need to account for the next power of the quadratic factor, which is x squared plus 4 squared. You see, I have to account for every power of that repeated quadratic factor. To the 1, to the 2. If it was to the third, I'd have to have another fraction. Again, in the numerator, we need another linear factor. I cannot use a and b because I don't know that their coefficients are going to be identical. So that's going to be cx plus d. I've got to use different letters. Now we have this set up to where we can actually solve for a, b, c, and d. The next step is to multiply both sides by the common denominator. And the common denominator is this denominator. So multiplying the left-hand side by the common denominator will completely eliminate the fraction, leaving us x squared plus 4x plus 2. On the other side, if I multiply by x squared plus 4 squared, I'll need to distribute to each numerator. And for the first fraction, this denominator will cancel one of those factors. Now that's going to leave me the numerator multiplied by the remaining factor. And then for the second fraction, x squared plus 4x squared, those are going to cancel completely, leaving me plus cx plus d. Next step, I need to get rid of the parentheses and then combine like terms. Okay, so in the next step, in order to get rid of the parentheses, we're going to have to do the FOIL method. ax times x squared, that is an ax to the third. On the outside, ax times 4, that is a plus 4ax. On the inside, b times x squared is a plus bx squared. Last but not least, b times 4 is a 4b plus cx plus d. And now to combine like terms. I only have one cubic term. He's going to come down. Hey, I only have one quadratic term, one squared term, plus bx squared. And then I have a 4ax and a plus cx. Notice both of those have an x. So what I'm going to do is factor out the x, leaving me 4a plus c. And then the 4b plus d, since neither one of those has an x, those are going to be my constant. 4b plus d, all of that together is the constant. Okay, constant. This is the coefficient of my x. B is the coefficient of x squared. A is the coefficient of x cubed. Now for that right-hand side to equal the left-hand side, the coefficients for each power of the variable, including the constant, Those are going to have to equal. So since there is no cubic term, there is no x to the third on the left, that tells me that the coefficient of x cubed must be 0. And so automatically I know a is 0. Now there is a squared term on the left. His coefficient is 1. So that must equal the coefficient of x squared on the right. And notice that that automatically tells me b is 1. Next, the coefficient of the x on the left is 4. That must equal the coefficient of the x on the right. Now that's going to give me the equation 4a plus c equals to 4. And last but not least, the constant on the left must equal the constant on the right. And that is going to give me the equation 4b plus d equals to 2. And now at this point, I should be able to solve for c and d. Notice that a and b are already solved for. So plugging into this first equation, if a is 0, 4 times 0 is 0, and that's going to tell me that c is 4. And then if I plug my b into my other equation, 4 times 1 is 4, 4 plus d is 2. Bringing the 4 to the other side is going to give me that d is negative 2. And again, once I know the values of all 4 of the variables, I can go back to the original setup, and that's going to give me my partial fraction decomposition when I plug in for a, b, c, and d. All right, back in our MyLab Math window. A was 0, so that would be 0x, which is not there, plus b, which was 1, over our first power of the quadratic factor, plus cx plus d. C was 4, d was negative 2, over our squared quadratic factor. This should be the partial fraction decomposition. And we're good. And listen, that's going to do it for this particular problem. If you have any questions or comments about anything covered in this video, please feel free to leave those in the comment section below, or you can text me. And thanks for watching.